Download this code from codegive.com, link in the description below. Resolving parsing fails with byte type issue 684 in grpc-web with code example. This tutorial delves into the common parsing fails with byte type error encountered when using grpc-web, specifically addressing the complexities highlighted in GitHub issue 684. We'll dissect the problem, explore potential causes, and provide a comprehensive solution with code examples. Understanding the problem, parsing fails with byte type. This error typically manifests when your gRPC web client attempts to parse a response from your gRPC server. The core issue arises when the client expects a string or a number but receives raw byte data in the response. This discrepancy can stem from several reasons. 1. Incorrect content type header ** grpc web relies on specific content type headers for serialization and deserialization. If the server doesn't set the content type header correctly, especially crucial if using application/grpc-web+proto, the client might misinterpret the incoming data. 2. Binary data in string fields * your proto above definitions might contain string fields that are unintentionally populated with binary data by the server. This is a frequent culprit, especially when dealing with image data, file uploads, or compressed information. 3. Improper serialization/deserialization * the grpc server-side logic or the grpc web client-side logic might not be properly serializing/deserializing data according to the protobuf schema. This can lead to data corruption or the transmission of raw byte arrays where strings are expected. 4. Incorrectly configured web servers/proxies * intermediate web servers or proxies, like Nginx, Apache, or Envoy, might be modifying or interfering with the grpc web response, stripping headers, or corrupting the data. 5. Client/server version mismatch * using significantly different versions of the grpc libraries on the client and server can sometimes introduce compatibility issues leading to parsing errors. Diagnosing the issue. Before diving into solutions, let's outline a strategy for diagnosing the problem. 1. Examine server logs * check your grpc server logs for any errors during the processing or serialization of the response. Look for exceptions or warnings related to data encoding or type mismatches. 2. Inspect network traffic * use browser developer tools, network tab, or tools like Wireshark to inspect the raw HTTP request and response headers and body. Pay close attention to the content type header, grpc status, and the actual data being transmitted. 3. Simplified test case * create a minimal test case involving a simple grpc method that returns a small, predictable string value. This helps isolate the problem and rule out complex data structures or business logic. 4. Reproduce the error * ensure you can consistently reproduce the error locally or in a controlled environment. This will make debugging and testing solutions much easier. 5. Review protobuf definitions * double check your .proto files to ensure that all fields are defined with the correct data types, string, int, bytes, etc. Pay close attention to any fields that might be receiving binary data unintentionally. Solution strategies and code examples. Here's a breakdown of potential solutions, accompanied by code examples to illustrate the concepts. 1. Verifying and correcting content type headers ****. Server side, example, Go. Explanation ****. The Go server uses the grpc package for the grpc part and optionally uses grpc gateway to create a reverse proxy for grpc web. grpc gateway automatically handles content type headers and other necessary transformations for grpc web compatibility. ***. The example shows setting up two servers, one gRPC server on port 9090, which your standard gRPC clients can use, and one HTTP/1.1 server on port 8080 that acts as a proxy for gRPC web requests. The gRPC web client connects to port 8080. Asterisk client side, example, JavaScript with gRPC web. Explanation asterisk. Asterisk the JavaScript client uses the generated gRPC web code to make the request to the gRPC web server. The gRPC web library handles setting the correct content type header, application/grpc-web+proto, automatically. Asterisk the key is to make sure your gRPC web client connects to the proxy server, port 8080 in this example, not the underlying gRPC server, port 9090. Asterisk important asterisk when configuring your web server, Nginx, Apache, etc., to proxy requests to your gRPC web server, ensure you correctly forward the content type header. The web server shouldn't strip or modify it. Configuration varies depending on the web server, consult its documentation. 2. Handling binary data in string fields asterisk server side asterisk if your protobuf definitions have string fields that are intended to hold binary data, example image data, compressed data, you should change the field type to bytes. Asterisk encoding/decoding asterisk when using a bytes field, you'll need to encode and decode the data appropriately. For example, if you're sending an image, you might encode it in base 64. Asterisk server side, Go. Asterisk client side, JavaScript. Important asterisk JavaScript doesn't have direct support for decoding byte arrays to strings. The code snippet uses to and string.from_char_code.apply, null, image data, to convert the byte array into a base 64 encoded string. This might require adjustments based on your specific data and encoding. 3. Correct serialization/deserialization asterisk review your protobuf code generation asterisk make sure you're using the correct protobuf compiler, protoc, and grpc plugin, protocgen grpc web, versions that are compatible with each other and your grpc libraries. Consult the documentation for your protobuf compiler and grpc web plugin. Asterisk server-side validation asterisk add server-side validation to your grpc methods to ensure that the data you're serializing and sending back to the client conforms to the expected protobuf schema. This helps catch errors early on and prevents corrupted data from being transmitted. Asterisk client-side debugging asterisk use browser developer tools to inspect the data that's being received by the client before it's parsed. This can help you identify whether the data is being corrupted during transmission or if the problem is with the client-side parsing logic. 4. Addressing web server/proxy issues asterisk header forwarding asterisk ensure that your web server or proxy is correctly forwarding the content type, gRPC status, and gRPC message headers from the gRPC server to the client. These headers are crucial for gRPC web communication. Configuration varies based on the web server. Nginx Apache HTTP/2 support gRPC typically uses HTTP/2. Make sure your web server is configured to support HTTP/2 if it's acting as a proxy. This is generally enabled by default in modern web servers. Buffering some web servers and proxies have buffering mechanisms that might interfere with gRPC web streaming nature. Consider disabling buffering or adjusting buffering settings if you're encountering issues. 5. Addressing version mismatches Update libraries. Ensure that your gRPC, gRPC-web, and protobuf libraries are all up to date and using compatible versions. Consult the documentation for each library to determine version compatibility. Dependency management. Use a dependency management tool, example Go modules, npm, yarn, pip, to manage your project's dependencies and ensure consistent versions across the client and server. Troubleshooting checklist. Protobuf definition. Are all fields defined with the correct data types? Content type header. Is the content type header correctly set to application/grpc-web+proto by the server? Base 64 encoding/decoding. If using bytes fields, are you correctly encoding and decoding the data on the server and client sides? Web server/proxy. Is your web server/proxy correctly configured to forward headers and support HTTP/2? Library versions. Are your gRPC, gRPC-web, and protobuf libraries up to date and using compatible versions? Network traffic. Use browser developer tools or Wireshark to inspect the raw HTTP request and response data. Example, full code scenario, Go server, JavaScript client, bytes field. 1. Protobuf definition, your_service.proto. 2. Go server, server.go. 3. Create a sample image, sample_image.jpg. You can create a small JPEG image and place it in the same directory as your Go server code. 4. Generate gRPC web client code. You'll need to compile your .proto file using the protoc compiler and the protoc-gen gRPC web plugin. The exact command depends on your setup, but it will generally look something like this. This will generate your _service_pb.js, protobuf message definitions, and your _service_grpc_web_pb.js, gRPC web client. You'll also need to generate the equivalent Go definitions. 5. JavaScript client, client.js. 6. HTML, index.html. Running the example. 1. Start the Go server * go run server.go. 2. Open index.html in your browser. This complete example demonstrates how to send binary image data using gRPC web with the correct protobuf definition, encoding/decoding, and web server configuration. Remember to adjust the code to match your specific use case and file paths. By meticulously following the diagnostic and solution strategies outlined in this tutorial, you'll be well equipped to resolve the parsing fails with byte type error and successfully implement gRPC web in your projects. Good luck.